Hi, everybody. Today I'm interviewing Andrew Mackay, I should say. Andrew is a UK-based electrical engineer with 30 years of experience. Andrew is an expert, particularly in analog and digital circuit design, product approvals, and quality management. He has worked for small companies but also for big corporations such as TT Group, Honeywell, New Brunswick Scientific. Colleagues of Andrew have said about him, Andrew is a highly competent approvals engineer, combining an in-depth knowledge of approvals with strong engineering background. And he's extremely adept at finding solutions for the most complex of technical problems. And due to his detailed approach and thoroughness, the design team always knew what would be approved and where change was needed. Andrew, welcome to the show.
Thank you, Han.
I'm very happy that we have you today because I think that you can share your experience in electrical engineering, but particularly product approvals. You've worked for small companies and big companies, as I said, and I have a few questions for you related to that. And maybe we can just start with a question. If you can explain me a bit in more detail what your work was as an approvals engineer, and which CE marking related directives you have worked with the most?
Yeah, sure thing. I suppose the most prominent directive would be the low voltage directive, and also the EMC directive, as they tend to be more generally applied to virtually every electronic assembly which is manufactured for use in the European Union.
Right.
Along with that, there's also the RTTE directive, which is the radio telecommunication telegraphy equipment directive, which applies to things like telephones and has side shoots into anything that has a radio attached to it, which is becoming more and more prevalent in today's environment. Along with those, we've got the ATEX directive, which is for hazardous areas, and I've been involved in a variety of solutions used to prove compliance with that. ATEX is a bit strange in that it generally tends to require third-party approval as a mandatory, whereas the others can be self-declared.
Yeah.
Pressure equipment directive, use this with small pressure sensors.
Yeah.
Manufactured in the United States and designed for the global market, which obviously pulls in the European directives associated with it. Machinery directive, again, this is a sort of electromechanical switch type directive. A lot of the high-end switches which Honeywell manufacture are used as safety devices, used for switching machines off, machine guards, that type of application. I've also been involved in aircraft components. I think back in 2000 there was a change in the regulations associated with components used on aircraft. Up to that point, you could actually, with historical evidence and competency, prove that you could actually authorize changes to aircraft components yourself as a manufacturer. However, come 2000, when the aircraft CE marking directive came into place, and you'll probably see this nowadays, that as you go into an aircraft, on your left-hand side, you'll see a CE certificate saying that the aircraft is CE certified.
Uh-huh.
So it seems a bit silly having a little bit of paper to prove that something as complex as an aeroplane is actually capable of flying.
Yeah.
But there you go, that's life. So I was involved in the changeover for the components on that. The change that involved was fairly drastic, whereas up to the point where that directive came into place, Honeywell could actually authorize and changes to their switch products. After that point, they could no longer do that. They had to go to the main sub-supplier, which tend to be people who are manufacturing undercarriage assemblies, where the switches were used to detect the positions of the actual undercarriage, doors and undercarriages and things like that, and from there gain their authority to implement changes. So that was quite a severe change in the way the process worked within Honeywell. Automotive components, not so much a Honeywell thing, more to do with autosonics and the reversing aids and reversing alarms. Likewise, military, NATO, US approvals associated with components used on munitions delivery devices supplied across the world. So there's mil specs and STANAG specs. So that basically is a summary of the type of work which I've been involved with. That's a brief summary.
That's a lot. Yeah, a lot of different different types of regulations. What, in your experience, are the biggest challenges that the European directives that you have worked with bring to companies? And you've worked for small companies and big corporations. Are these challenges the same, or are they different? What would you say are the biggest challenges?
I would say that the challenges tend to be very similar, but very different. You tend to find that within large companies that the activities have more resource available to them in terms of man hours, but tend to be more financially restrictive. So, for instance, if you're making an application for an external type test, then within a small company, you could probably do the approval and get the payment made within an hour. Then something like Honeywell, you'd be lucky if you could do it in a week.
Yeah, I can imagine.
But then again, the frustration of a small company is that you no longer have a diverse range of human resource to actually carry out activities, and you end up being very much self-reliant.
Yeah.
Which can be a bit confusing at times. You know, one day you're working on the actual design work, and then the next day you're actually working on approving the design work. So you get confused as to whether you should be saying yes or whether you should be saying no to actual approval.
Yeah. And in your time, what are the biggest mistakes that you have seen companies make in terms of compliance engineering and approvals?
I think probably the biggest mistake is that people tend to leave the actual approval and compliance activity until the design is finished. They don't think it is a part of the design process. They don't believe that approvals has anything to do with design. This can be disastrous. If the design team is working along a path and comes to the end and submits it for approval, and the approval process rejects it and says that the design is actually wrong, it can mean that the design goes back to the start.
And thus causing potentially a lot of delay in bringing the product to the market. Yes. Mm-hmm.
Yes, indeed, and also, along with the time delay, there's also the costs involved. In other words, you're ripping up design work which has been carried out and has to be thrown in the bin.
Yes, because maybe you have to introduce new components which are more expensive in order to, for example, bring down noise levels, electrical EMC noise levels.
Yeah, there's the EMC aspects, but also within the low voltage part of the scheme of things. I've no idea why the low voltage directive was called the low voltage directive, other than that is associated with a certain voltage level, 50 volts AC. It's got very little to do with voltage at all. It's to do with safety, not just electrical safety. It's also fire hazards as well are covered under the low voltage directive.
Yes.
What's fire got to do with voltage? Very little at all. It would be far better if they just said electrical safety directive.
Yes.
And that would have maybe conveyed a bit more importance to what's it actually contained. So, for instance, you could end up producing a product which has got the wrong plastic type. Just to explain, obviously, there's UL ratings for plastics, which contain the self-extinguishing properties and the amount of time that it takes for plastics to extinguish after they've been ignited. The horrific ones are when it is a UL 94 VHB, which allows for a horizontal burn, but then again it still doesn't allow for small drops of molten flammable plastic dropping off the object and setting fire to other things, which is a very, very nasty situation that you really don't want to be in with a product.
Yeah.
I think at the start I stressed that the low voltage directive was probably the most important one, and from that aspect you really don't want to have in your career a product that's actually killed people.
That's right. Yeah.
I mean, EMC, there is the potential there to be disruptive to people's lives, but in general you can always switch the device off.
Yes. Now you spoke about the importance of considering product approvals already in the stage of the design. How do you implement EMC and electrical safety in a design?
I wish there was a magic wand that you could wave, Anne,
Yeah.
that could actually implement EMC and safety within a product. Unfortunately, it's not likely to happen in the near future. In fact, it's not likely to happen at all.
Yes.
Certainly with things like EMC, there's a variety of documented texts on how to do, for instance, printed circuit board layouts,
Yes.
grounding arrangements, metal screening, unfortunately, practical experience would tend to indicate that some of that information is complete rubbish. And unfortunately, the only way you can find out is through practical experience.
Yes.
I think my favourite one is the metallized paint on the inside of plastic enclosures. Generally, it just doesn't work in comparison with a metal box.
Yes.
You know, it's far, far inferior to a metal box.
So for EMC, it's rather challenging. I guess you need to have a lot of experience testing, retesting, trying new things in order to get a better feeling for how you can prevent EMC disturbances from occurring. But what about the electrical safety? My impression was also always that with electrical safety, it's easier because you can do a lot of visual inspections. A lot of the requirements and standards are related to tests and inspections that you can do easily yourself. Is that correct?
Yes. Generally, a lot of the electrical safety aspects of a product can be measured physically. Mm-hmm. And documented via things like flammability ratings for wire insulation and enclosures. So you've got a type of plastic, you can look it up on the UL website and it'll tell you what the flammability rating is for that particular type of plastic. The UL website contains, that last count was somewhere over 300,000 different types of plastic, and they all have their own UL flammability ratings.
Wow.
So it's a very useful resource, and if you haven't already got access to it, I would thoroughly recommend that you log on to ul.com and look under the IQ for plastics. Register your email. It's free. What can you say? You can't get much better value for money than that.
Yeah. Andrew, from your experience, how long does the average approval process take from design up to the shipment, basically? And what parts of the approval process tend to be underestimated?
Well, Han, you've asked another question which is somewhat similar to how long is a piece of string? How big is a drop of water? It very much depends on the actual approach of the actual project itself. You can circumvent the risk of failure by involving approvals at the actual inception of a project, going and speaking to approval laboratories, making sure that you have the correct approach for the particular application for the end use of the product. Make sure you have the correct version of standard that is going to be used by a test authority to actually evaluate the product. And to answer the question, well, I've seen approval processes last anything from as short as 4 weeks from submitting samples to well over 2 years.
Wow. Yeah.
The particular instance where it's over 2 years I'm thinking of is where the product itself was not fit for purpose. It had started off as a particular design, and through time they'd stretched its current rating. It was an electrical switching device, and it had started off at 8 amp rating, and they'd stretched that to 21 amps. Needless to say that when it went for revision to the actual European standard that was used for its certification, which deleted its previous standard. I think we had, on first pass, we had a 90% failure.
Yeah.
And that was iterative. So of that 90%, the next time we submitted a range of samples, 90% of that failed, and so on until we got down to nothing.
Oh. But as you say, I think correctly, in this first phase, you can also, specifically by looking at the intended purpose of a product, you can also prevent a lot of problems by choosing the correct directive and choosing the correct category sometimes in directives, and also by choosing the correct standards, right?
Yes, absolutely. Mm-hmm. It's very important to be upfront and honest with the actual testing authorities that you're trying to get feedback from on how you should be approaching the approval process for your product and its intended application. If you're not honest with them, the information they're going to give you is going to be rubbish. And when you actually come to submit it for testing, you'll find that it actually fails because you weren't honest.
Mm-hmm. And what other tips could you give to the audience about how they could save money and time on the EMC testing and the product safety testing?
Yeah, there's a couple of tips. I've already mentioned that you shouldn't rely on the approval process as being something that you plug money into at the end of the design phase and a certificate comes out of the output tray, as it were, of the process. It's far more important to involve the approvals process at the start and also during the product development. So as the product develops, as parts of the finished assembly are completed, you do pre-compliance testing on those parts. Yeah. So you've got a degree of confidence that when the complete assembly is put together, it is all going to pass. Whereas if you blindly go forward, assuming that they're going to pass, bolt them all together, and suddenly find that none of it works,
yes. Yeah.
It can be a bit of an eye-opener. Mm-hmm. One of the other things which I haven't mentioned is that if you have a wide variety of products, which are all very similar, mm-hmm. Then what you should really be considering is generating what I would describe as a product table, mm-hmm. where you have each of the individual features as part of the part number for the actual finished assembly. And from that, you can actually generate an approval matrix, which reduces the amount of testing that's required and involves doing approval testing by what's termed by similarity.
Yeah, it's a kind of clustering, grandfathering. I think this is often called.
Yeah, it's making a product family. It's not grandfathering. Mm-hmm. That's a different process altogether. Mm-hmm. Grandfathering is taking approval from a previous product and applying it by grandfather's rights, as it were, okay. to a new product. Mm-hmm. Whereas what I'm talking about is more like brother and sister mm-hmm. Approval. Creating a product family of, I've got this generic switch as the center part, and then I can have different types of contact on that. I can have a gold wire contact, I can have a silver contact. I can have a gold-plated silver contact, that type of arrangement.
Mm-hmm.
In fact, in some instances, you can actually do a sort of worst-case type approval process. So, for instance, if you have a silver contact, which is rated at 10 amps, you can do the heating or self-heating tests on that particular model, and you can use the results from that to say that the gold contact and the gold wire contact, which have got a much lower current rating,
Mm-hmm.
won't have the same self-heating effect. Therefore, they're also approved because you've approved the 10 amp silver one.
Yeah.
Thinking smarter rather than working harder.
Yes. So that is allowed.
Sorry?
So it means that according to the regulations, that is allowed.
Yes.
Yes. Yes, because it's basically it is the manufacturer's responsibility to prove compliance, right?
Yes. From the work within Honeywell to approve each individual model of one particular range of switch, there were an almost infinite variation in the actual construction of the actual switches. The actual current catalogue contains 5,000 different switches, and each switch would take 3 months to test.
Mm-hmm.
Which means that we would all be both long buried before the testing was ever finished.
Mm-hmm.
So, in other words, you don't have any choice in the matter. You have to do it smarter. You have to do it by similarity. You have to group things into families, and you have to identify the different constructions so that you can say, well, I've approved that one, so I just need to approve that part of the next construction, and that covers me for that part of the family, and so on.
Mm-hmm. At Honeywell, did you used to have your own EMC and electrical safety test facilities?
Yes and yes. Yes, we had our own EMC test facility,
Mm-hmm.
which was above and beyond pre-compliance. You could actually do full compliance testing in the EMC facility.
Mm-hmm.
Given the quantity of electromechanical switches that were being produced, we also had a permanently staffed test facility that was both doing production audits
Mm-hmm.
and doing design testing. They had their own machines for doing the actuation of the switch devices. One of the more amusing machines was the mechanical life test machine. Some of the switches had such a long lifetime on the mechanical actuation that they actually derated them so that they could get the results out within a year. So these machines would sit there going backwards and forwards, activating and deactivating the switches, and they could run literally for months on end.
And would you, besides using your own laboratories there for full compliance testing, would you then use a third-party test laboratory in order to get some kind of certificate, or it was sufficient for you to have your own test results?
The division which I worked in within sensing and control as part of Honeywell had a bit of a strange attitude towards compliance testing,
Mm-hmm.
in that although they produced enough information and had enough test results to do a self-certification, they never actually did that themselves.
Okay.
They preferred to actually have virtually 110% certainty of passing the tests on the product
Mm-hmm.
and submitting them for testing as
Mm-hmm.
almost a paperwork exercise. And it was a real sort of shock if things didn't pass when they went for full compliance testing by a third party. Um, the philosophy behind that was that the laboratories, external laboratories, had third-party liability insurance running into several millions of pounds, and Honeywell didn't want to become involved in that sort of insurance type activity.
Mm-hmm.
Prefer to offload that, as it were, to a third party.
Mm-hmm.
Um,
Well, in any case, I would say the test facilities, the full compliance test facilities, helped you to do a lot of testing in the design phase to make sure that by the time that you are ready to send samples to a test laboratory, that they were going to pass. Correct?
yes, I mean, Honeywell's on-site facilities provided that. Obviously, with smaller companies, you don't have the on-site facilities, but there's nothing stopping you from using
Mm-hmm.
a third-party approval
Mm-hmm.
organization to do your pre-compliance testing with you, um, as long as you don't mind going there and coming back
Mm-hmm.
and having the embarrassment of um, doing a pre-compliance on a product and have it fail.
Mm-hmm.
But then again, it's cheaper to do a pre-compliance and have it fail than it is to do a full compliance and have
Mm-hmm.
it fail.
Maybe you, for those that don't know or don't understand the difference, can you briefly explain the pre-compliance? What is the purpose of doing a pre-compliance test?
A pre-compliance test is usually a reduced testing requirement, and it's usually carried out faster, so it takes less time.
Mm-hmm.
It's usually carried out on sub-assembly rather than the full assembly.
Mm-hmm.
It enables you to get test results and feedback into your design process.
Mm-hmm.
So if a design iteration is required,
Mm-hmm.
it can be carried out at an earlier stage in the design process rather than at the end. Obviously, within a design process, up to the point where you're releasing a product for doing full compliance,
Mm-hmm.
um, the design is in a state of flux. In other words, things change and can change quite rapidly.
Mm-hmm.
Once you actually release a product, it takes a lot longer for things to change. You're talking the difference between a matter of minutes
Mm-hmm.
in the sort of pre-compliance state, as opposed to several days, maybe even weeks, at the full compliance state.
Mm-hmm. At least after a pre-compliance, I think typically what test engineers do is they try to make an estimation where they expect problems with complying with the requirements of standards, and then test against those particular points in the standards. And at least if you pass those tests, there is a bigger chance that you will pass the full compliance test. Correct?
Yeah,
Mm-hmm.
yeah. The other important thing to be aware of is that, in general, um, third-party test house, when they are doing a compliance test, will do the compliance test, and at the point where they hit a failure, they'll actually stop. So you won't know if the bit of testing that has to be completed to complete the compliance testing
Yeah.
that has not been carried out, whether or not it's going to pass or fail. Pre-compliance testing allows you to go beyond that failure point, and you can carry out all the tests that are required. So you get all the feedback in one go, and you're working on all the failures and non-compliances in one shot, rather than sort of getting it drip-fed to you. Remembering that external test facilities run on very much on a commercial basis, and they tend to book their time in hours and sort of minutes. So every sort of time that they stop, your project or product is put on the shelf until you fix it. And they don't carry on working and worrying about your product. They just stick it on the shelf and start working on another one.
That's right.
Because their investment in their test facilities has to be recuperated. They can't leave it sitting there on their test facilities sitting idle. They have to try and use it sort of 100% of the time that's available.
You are currently available for design, product approval consulting. Is that correct?
That's correct, yes, ma'am.
What are the type of activities that you would be looking for? What kind of jobs could you provide to companies who would like to use your expertise and your experience?
Yeah, I think my expertise tends to lie with the area between the real world, the sensing element, the analog interface to the sensing element, and the interface to whatever's going to be using the information that the analog device has detected. And obviously, as you're aware, I have quite a bit of experience in design-related activities like approvals.
You are looking for opportunities to do consulting jobs or being employed?
Yes.
Yes.
Either.
Okay.
Yeah. Either permanent or contract.
Okay. Very well. So thank you again for the interview. If you are watching this interview on YouTube, that's great. We would invite you to subscribe to our channel, so we'll get more viewers through this way. We'll be producing these types of interviews of experts on a more regular basis starting from now. So we would also appreciate if you give us your ideas about questions that you have and persons that you would like to us to speak with, and specific expertise that you would like us to go into. So please subscribe to our channel. Please send us your email messages. We look out for them. Thank you very much. Thank you, Andrew, again.
All right, thank you for listening.
Bye-bye.
All right, bye.